Yes. All right, guys, we're looking at one of the questions from the homework from Monday. Question number 15. 7.1. Okay. All right, guys. Focus up here. Number 15, use the given values to write an equation relating x and y. And x and y vary inversely. Use the given values to write an equation and then find the value of y when x is 3. So since they vary inversely, y is equal to a over x. So to find the equation, we need to find the value of a. So the first thing we can do is plug in our x and y value, because we know x, whenever x is 5, the y value is -4. So for this here, whatever a is, when we divide it by 5, we get a y value of -4. So at this point here, we need to solve for the value of a. So to undo the multiplication, we would, or not multiplication, when we undo the division to get a by itself, we would multiply by 5, giving us a by itself. And what we do to one side, we have to do to the other. So 5 times -4 is -20. Telling us that the equation is y equals -20 over x. Questions on this here? Now that we have the equation, we need to find the value of x, or y, when the x value is 3. So we take that equation, y equals -20 over x, and plug in 3. So we have y equals -20 over 3. We would reduce this. So -20 over 3 is -20 over 3. Since it doesn't reduce, that's our final answer. If it did reduce, then we would reduce it. But because it's thirds, we can leave it as this here. I wouldn't convert it to a decimal because we would have a repeating decimal number going on forever. But that's it. So y equals -20 over x, and y equals -20 over 3. Questions on this here? All right. Now we are going to pick up with where we left off yesterday, multiplying rational expressions. Multiplying rational expressions. When we multiply two rational expressions, we multiply straight across. Numerator with numerator, denominator with denominator, and then simplify from there. Now, that's all we need to do. So we would multiply the 5x squared and 6x times y cubed, our 2x y squared and 10y. We would multiply those together and simplify from there. So when we look at this first one here, there's different ways and processes we could do this, because we could turn 8 into the prime factorization, which is 2 times 2 times 2, and break it down in different ways. But I think the easiest way for us to do this is to just multiply first and then simplify second. So when we look at the numerators, the tops, we're going to multiply the two numerators. So we'd have 8 times 7, which is 56. We can do that in a calculator, 8 times 7. We can let that do it. Let the calculator do that for us. Then we can multiply our variables, x to the third and x to the fourth. When we multiply like bases, we add the exponents. So our x to the third times x to the fourth would be x to the 7. Our 3 plus 4 would give us 7. And lastly, our y times y to the third. Well, we have y to the first times y to the third. So our 3 plus 1 is 4. Our denominators, we would do the same. First, we're going to start with our numbers, our 2 times 4, which is 8. Now, since we only have one x, we don't have an x in the other spot. We would just have x to the first. And lastly, we have y squared times y, or y squared times y to the first. So our 2 plus 1 would give us y to the third. So once we finish multiplying, then we simplify. Now the first thing we can simplify is our 56 over 8. They would both be divided by 8. Because 56 divided by 8 is 7. It reduces to 7 over 1. So we can put the 7 on top. We don't necessarily have to put the 1 in the numerator, especially if there's another variable or term there. Or if it just becomes 1. Now when we divide like bases, when we divide two like bases, we subtract the exponents. So our 7 minus 1 is 6. If it's bigger on top, it stays on top. If it's bigger on bottom, it stays on bottom. So our 7x, or x to the 7th, over x is going to reduce to x over 6, and it would be in the numerator. Our last one, y to the 4th over y to the 3rd. It would be y to the 1st, and since it's bigger on top, it stays on top. There would be in the 1 in the denominator, yes. 6. Right, since it's dividing by 1, we don't have to write that division of 1. We can leave it as 7x to the 6y. Now, we do have restrictions. It didn't ask for them, but we can list them. And here, x and y, incidentally, both cannot be 0. Since we're multiplying, especially 8x times y to the 3rd, two or more things multiplied together to equal 0, one of them must be 0. And it actually works out that both x and y would be 0 in order to make the denominator be 0. So x and y cannot be 0. Questions on this here? Let's look at another one. 6x squared y. Thank you. We'll find out shortly. I will. Have a good rest of your day. So this one here, 6x squared y times 9x to the 5th y squared is what we'd multiply first. Then we would multiply our 3xy cubed into y. Because we multiply straight across. When we multiply two fractions, we multiply numerator with numerator, denominator with denominator. And again, there's different ways we can do this. So if we do straight multiplication across, first thing we're going to do is 6 times 9, which is 54. X squared times x to the 5th is x to the 7th. Because when we multiply like bases, we add the exponents. Y times y squared would be y to the 3rd. Because our y without an exponent is y to the 1st, y to the 2nd, so our 1 plus 2 gives us 3. The denominator, our 3 times 2 gives us 6. Again, just like the last one, we only have one x in either denominator, so it's just x to the 1st. And y cubed times y is y to the 4th. Because y to the 3rd times y to the 1st, 3 plus 1 gives us 4. Now our last step is to simplify. Our 54 over 6 would reduce to what? It would reduce to 9, because we can check it on the calculator. 54 over 6 is 9 over 1, or just 9 in the numerator. X to the 7th over x. X to the 6th, because our 7 minus 1 would be 6. And since it's bigger on top, it stays on top. Our next one, y to the 3rd over y to the 4th. So again, we could say 4 minus 3. 4 minus 3 is 1. It would technically be negative 1. but since it's bigger on bottom, it stays on bottom. So we would put y to the first on bottom. Now, yes, according to the theorem, and I'm going to show this here, 9 is what we had first. We would go through and subtract exponents. X to the 7th over x to the first, 7 minus 1 would give us x to the 6th. And strictly according to this theorem with division, we would subtract the variable's exponent on top minus the variable's exponent on bottom, which would be 3 minus 4, which is -1. And we would say y to the -1 and have it all in the numerator. But we cannot leave an exponent with or a negative exponent. So to make the exponent positive, anytime we have a negative exponent, we can move it from the numerator to the denominator and make it positive. That's how we keep the exponent being positive. Does that make sense? So we would take this y to the -1, move it to the denominator, and we get this here. So we kind of see how that works, yes, and it's, I think, something y'all have done before with negative exponents, but I think it's sometimes easier just to subtract it. Whichever one had the most is where it stays, because we're more or less canceling those out. We canceled 3 of the y's on top with 3 of the y's on bottom. We had 1 left over. And again, x cannot be 0 and y cannot be 0. Questions on any of this here? Questions on anything we've done so far? Let's look at one more of this type and then we're going to move on. For this one here, again, we can multiply our numerators first. 3 times 6 is 18. X to the 5th times x. Oh, here we have 5. How many do we have here? 6. Which is x to the 6th. X squared, or y squared times y squared. Y to the 4th. The denominator, first thing we have is 8 times 9, which is 72. Now we have x times x to the 3rd, which is x to the 4th. And y times y is y squared. Now at this point here, we do need to simplify. 18 over 72 is 1/4. 1/4, so we will have the 4 on bottom. And it does make sense that the bigger value should be on bottom because the bigger number is on bottom. Now we have x to the 6 over x to the 4th. 6 minus 4 is 2. Bigger on top stays on top. Y to the 4th over y squared. 4 minus 2 is 2. Since it's bigger on top, it stays on top. So we have x squared, y squared over 4. Questions on any of these here? So what we did just there and what we've done in the last few is multiplying what we call monomials, one term. Top and bottom is a single term. We don't have addition, we don't have subtraction, they're a single term. We call these polynomials, they're many-termed expressions. So 2 or 3, and we do have a monomial, the 3x. Now whenever we multiply polynomials, guys, let's focus up here. Let's focus on this here. We need to factor them if they are factorable. Some of them, it might be just a greatest common factor. Others, we might need to use our 2 sets of parentheses. Or in the 3x's term, it stays the same. It is a single term. We can't factor it. We cannot factor monomial single term expressions because there's nothing else to factor it with. But now we need to pick from the other 3 of which one we want to factor first. Top left, 3x minus 3x squared. And again, the first thing we should be factoring is a greatest common factor, which is 3x, because we look for what's in common in every term. Both terms have a common factor of 3. Both terms have a common factor of x. And we factor 3x out of 3x. Since everything factors out, it reduces to 1. Minus, when we factor the 3x out of 3x squared, 3 factors out completely. We factor 1x out of x squared, leaving us with x. Now we need to pick from the other two to factor. X squared plus 4x minus 5. Now x squared plus 4x minus 5, since the third term is negative, our signs are opposite, positive, negative. Now we look at the factors of the first and third term. Factors of our x squared are x and x. Factors of 5 are 1 and 5. Where would we put the 1 and 5? So we'll put 5 with the plus, 1 with the minus. If we do check this, x times negative 1 is negative x. 5 times x is plus 5x, giving us positive 4x. So that is the middle term we want. And if you are checking it, make sure to check them off to the sides, or put your scratch work on the sides, because again, we're still having to multiply these together. It's not the final step. Now the last thing we need to factor is the x squared plus x minus 20. Now again, if something's going to reduce, we need to have something in common on top and bottom, yes? So we're looking for one of these sets of parentheses to be either x plus 5 or x minus 1. Now if we look at this here, the third term's negative, so our signs are plus and minus. Factors of x squared are x and x. Factors of 20, 1 and 20, 2 and 10, 4 and 5. Which one looks like it could work? X plus 5 and x minus 4. And one of the reasons we pick it, because again, we can get one of them to match up, the x plus 5 and x plus 5. Really, that's the only one that matches up without using 1 and 20. And there's a good chance that's not going to give us a middle term of x. And again, off to the side, we can say x times negative 4, negative 4x. 5 times x is plus 5x. 5 minus 4 does give us a positive 1. Questions on how we got to this point here? We ready to multiply these together? All right. So we're going to multiply the numerators together, yes? Well, 3x, parentheses 1 minus x. Well, the parentheses in our 3x are being multiplied together, yes? So if I want to multiply the other two parentheses with it, well, we still have the 3x out front, 1 minus x, and then I would just write x plus 5 and x minus 4. We multiply them. Well, two sets of parentheses next to each other is understood to be multiplication. So more or less, we put the parentheses next to each other. We'll do the same thing with the denominators. We're taking our x plus 5 times x minus 1 and multiplying it by 3x. Anytime we have monomials, single terms, it is going to be helpful to move them to the front. It's easier to have them in front than have them in the middle or in the back. Questions on how we got to this point here? We good with this here? What's in common on top and bottom? So 3x over 3x would reduce to 1. X plus 5 over x plus 5. Leaving us with one minus x, x minus 4 over. Now, it is unfortunate 1 minus x and x minus 1 are very close to each other, yes? They're not exactly the same. Let's try something. What would happen if I factor a negative 1 out of 1 minus x? If I factor a negative out, remove the negative from the negative x, it becomes x, yes? What happens if I remove a negative from positive 1? Because we take the negative away from x and it turns it from negative to positive, yes? So what happens if I take a negative away from a positive? It becomes, yeah. Because a negative times a negative is a positive. So, because if we multiply, and I'll write this out to the side, because if we had negative 1 times x minus 1, our negative 1 times x is negative x. Our negative 1 times negative 1 is plus 1. So negative, parentheses, x minus 1 is the same as 1 minus x, yes? Well, why is that helpful? Now what do we have in common on top and bottom? X minus 1 and x minus 1, yes? Which leaves negative minus 4. So, now that seems like a very odd kind of assumption to make. Why would we do that? Why would that even be in the realm of possibilities? And it's something we need to look for, and there's a big kind of indicator that helps once we see it. Whenever we have two expressions, and I think we would agree that we can see that these two are very similar to each other, yes? If they are essentially the same, but the signs are flipped, both signs are flipped, we can factor a negative 1 out. Almost the same as when we did greatest common factor, where the first term was negative. I factor that negative out, turn the first term positive, and switch the signs all the way through. Same exact thing. Because we can factor a negative 1 out of anything. Because x minus 4, well, it'd be helpful if I'm not writing in the highlighter. So x minus 4. We could factor a negative 1 out of this. We can pull a negative 1 out. And if I factor a negative 1 out of positive x, it becomes negative x. If I factor a negative out of, then it becomes positive. Because by pulling that negative out, we're changing the sign of both terms. Yes? Yes. And a way we can check and make sure we factored it correctly is off to the side we can multiply it back through and see if we get back with what we start. Negative 1 times negative x would be positive x. Negative 1 times positive 4 is negative 4. Now, it seems like an odd intuition. Why would we do this? But again, when we looked at the two terms, 1 minus x, x minus 1. The x on top was negative. The x on bottom is positive, yes? The 1 on top is positive. The 1 on bottom is negative. When every term in that one that almost lines up is flipped, they're the opposites of each other all the way through, pulling that negative out is going to flip the signs back. Does that make sense? Or, if we look back at the start here, 3x minus 3x squared, is that in standard form? Well, no. Standard form, negative 3x squared plus 3x. Negative 3x squared plus 3x. Again, in factoring, it's nice to leave that biggest term positive, yes? So what we could have done instead is, instead of factoring out 3x, we could factor out negative 3x. And we do that, the 3x squared becomes x. our positive 3x becomes negative 1. We get that there. Huh? 4? Questions on how we got to this one here? Questions on how we did this here? We were ready for the next one. We can, yes. So we can distribute back through and get negative x plus 4. I will take either. Negative parentheses x plus or x minus 4 is the correct answer. Negative x plus 4 is the correct answer. They're just two different ways to write it. Now, if we do get an answer like this here, so guys, again, if we do get an answer like this here, negative x plus 4 times x plus 2, that is the final answer. You do not have to multiply the x plus 4 and x plus 2 back together. Does that make sense? We don't have to redistribute and say that this is x squared plus 6x plus 8 and then multiply the negative back through. You can leave it as is here. Questions on this so far? We are going to do another one that is pretty much the exact same thing. We just changed the numbers. Now again, this part here, we realized the first thing before we can actually multiply is factoring. That's why we went back over factoring again, so that y'all are comfortable with this. Because the more comfortable you are with the factoring, the less time a lot of these problems are going to take. Well, just like with the last one, this top numerator, they're flipped again, yes? We can straighten them out. Let's go on and just do that for our first step for this here. Because I believe that's going to make things a little bit easier. Because just like the last one, if we left it as 5x minus 5x squared, we can factor the 5x out, but our x term is going to be negative. And there's a chance, so we'd have to pull it out later. Now we have the other two, x squared minus 4x plus 3 and x squared minus 5x plus 6. We need to factor both of them, but we need to pick one that we can feel more comfortable with doing first. Which one do we want to factor first? X squared minus 4x plus 3. It really doesn't matter which one we factor first, but I would pick one that I can see the factors of easier. So if you see the factors of the denominator easier, do it first. If you see the factors of the numerator one, do it first. Because if we look at x squared minus 4x plus 3, since the third term is positive, the signs are the same and match the sign of the middle term. So minus and minus. Factors of our x squared are an x. Factors of 3 are 1 and 3. Now off to the side, if we want to check and make sure this does work, we'd have x times negative 3 is negative 3x. Negative 1 times x is negative x, which does give us a middle term of negative 4x. Now we need to factor the numerator. Since the third term is positive, the signs are the same and match the sign of the middle term, which would be negative and negative. Factors of our x squared are x and x, because the only number in front of it's 1, so we just have x and x. Factors of 6. We have 1 and 6 or 2 and 3, yes? We'd use 2 and 3, because if we're going to have something that simplifies, we need something to match up with our x minus 1 or x minus 3. So both of them do have at least one of the terms, but to get a middle term of -5, we are going to use 2 and 3. And if we check this one off to the side, x times -3 would be -3x. -2 times x is -2x. And -3 minus 2 is -5x. Well, we still have one thing left to factor, our -5x squared plus 5x. Yes? So we need to see what's in common with both terms. We'd agree with the 5, yes? And we also have x. And again, just like when we went over factoring the first time, it's been a while. We really want to try to keep that biggest term positive. Because here, our first term, our x squared, is negative. So even factoring the 5x out of both, it's still going to turn that first term in the biggest one. So instead of just factoring out 5x, we're going to factor out negative. Because our -5x squared, the -5x, or -5 will factor out completely. Our x squared is going to become x. It's going to turn it from -5x squared to our first term being positive x. 5 and x both factor out completely, giving us 1. But our sign's going to go from positive to negative. And again, what do we have on top and bottom? X minus 1 and x minus 1, yes? So that will help us in simplifying this down. So what we have when we multiply these is we will have the 5x times x minus 1, but we're also multiplying it with x minus 2 and x minus 3, the denominator. We'll have the 5x, but we're multiplying it with x minus 1 and x minus 3. What's in common? 5x and 5x.
Yeah.
We also have the x minus 1 and x minus 1. I accidentally wrote that as x minus 3. And we also have the x minus 3 and x minus 3. Negative x minus 2. So we have the negative parentheses x minus 2 close parentheses. Questions on this here? Questions on anything we've done so far?
How do you organize it to the little, like how you did on the marking them out?
When we multiply we multiply straight across. So we multiply all the numerators together. When we put parentheses next to each other, we're saying that they're being multiplied. So really, we can just condense it down to 1. Same with the denominator. Now, it feels like we should have x minus 1 times x minus 3 times the 5x.
Yeah, that's what I was curious.
But because 2 times 4? And 4 times 2? Because no matter how we multiply two things in any order, they are the exact same, yes? So what we do to keep it in nice order, we take that 5x and move it to the front. Because we can leave it in the back, but then we put parentheses around it, we have to do a little more with notation. But we can move those monomials to the front. Questions on this here? I think some of y'all are noticing the biggest linchpin in this whole thing is factoring, yes? Because once we get it factored, everything else flows very nicely from there. And one of the nice things with this is that the factors for some of the rest of them will give us and help us find the factors of the other. Because if we don't have something matching up, it doesn't reduce. Now, if we look at the numerator, 2x squared minus 10x. 2x squared and 10x have a greatest common factor of 2 and x. Now when we factor 2x out of 2x squared, we're left with x. Minus, when we factor 2 out of 10, we have 5. X factors out completely. X squared minus 25. I hope by this point this is one of the nicer ones to factor. So the 2x would just be 2x. Yes. So the question is, would this 2x squared on the bottom stay the same? Yes. Because it is a single term. And the x plus 3 on top, since we're over here, would also stay the same because x and 3 don't have a greatest common factor. Since the degree is 1, we can't do our 2 sets of parentheses and factor there. So that's as simplified as it gets. So that's as far as that one goes. X squared minus 25 is a difference of perfect squares. X plus 5, x minus 5, guys. Now at this point here, we can multiply this together. So the numerator would be 2x times x minus 5 times x plus 3. The denominator, we can move the 2x squared to the front and have our x plus 5 and x minus 5. Now the nice thing for this here is the x minus 5 and x minus 5 would cancel. The 2 over 2 would simplify out completely, leaving us with x plus 3 on top and x plus 5 for sure. But we do have x over x squared. X, because it's x to the first over x squared. 2 minus 1 is 1. Since it's bigger on bottom, it stays on bottom. So we have x plus 3 over x times x plus 5. We will be finishing this tomorrow. The assignment is posted in Google Classroom. If you want to get started, you can do a good portion of it. Yes.